So firstly, I'll be talking about what is explorative data analysis for EDA. So EDA is basically like getting the data before actually performing any operation. So most people will confuse explorative data analysis with visualization, which is basically visualizing data. So visualization is showing data, but explorative data analysis is questioning the data and getting insights. So one example of questioning the data is if I question that how many of the NFL players were born in a certain month, and now I would expect that all the months are equally distributed, and equal amount, almost equal NFL players are born in January or December, right? But if you actually then you can see that 40% of the NFL hockey players were born in the first quarter of the year, and only 10% were born in the last quarter. So this doesn't make sense, right? Because the month you were born doesn't tell about your hockey life. So, you guys have any idea how this happens? Okay. So what is happening? So in Canadian youth hockey, the age cutoff starts from January 1. So if someone was born on January 2nd, and if someone was born on December 31, they would have almost a year's age gap. And they start recruitments from the age of 9 to 12. So that 1 year age gap matters a lot because people who are older are actually stronger and they have more abilities. So the coaches think that these people are better, and in the future, this becomes all feedback. So this small early advantage leads to better opportunities, and these better opportunities lead to more development of the people who are born in the first quarter. And this gives a much longer long-term advantage to people who are just because they're got. So if we never did the data analysis of such a random question, we would never find out that why this kind of anomaly is coming. So next, let's talk about anomalies. So anomalies are the unexpected event in the data. So if you have a somewhat of a uniform data, okay. So an anomaly can basically make or break your data. So how you can make your data is, let me give you an example. For example, you have normal transactions, like let us say an example of a daily transaction, you're spending 50 every day or like some amount in the canteen every day, and suddenly you see a huge transaction from a bank. That is an anomaly. So this can be used for fraud detection. Another anomaly is the conflict this strategy showing on the running conflict. So anomalies can help us detect fraud, it can help us detect machine failure, security attacks, etc. But sometimes anomalies are just errors. So anomalies sometimes are just errors, cycles, or broken sensors, and this can totally break your data if you're going for if you're further operating on your data. For example, I have a very simple data of 3 numbers, okay, which is 1, 2, 3. But if you add another number, let's say 100, and this is an anomaly, okay, and you accidentally added your data set, then your graph and everything will completely change. So an anomaly can really affect your data. That's why when we clean the data, we usually remove outliers. So basically, you can see this data. This data basically shows the number of characters and words of our depression detection data set. So this data set has been scraped from Reddit, okay, from the depression subreddit, and we kind of saw the number of words in each text. Some of the data is kind of like not necessary, like it really the amount of data. So in this data set, there's no significant anomaly. Like I won't say that if someone has written 5 paragraphs, it will make a huge difference in our estimation. So that's why we use this word outliers. This data that is not standard or uniform to our calculation. So, for example, in these data sets, you will most probably see the most character entries with greater than characters or less than 60 characters because they will not be helpful for us. Okay, so before I talked about data visualization, and I also talked about how EDA is different from data visualization because in EDA you question and in data visualization you just show. So this is what basically data misinterpretation is very common these days, where journalists and others are going to just listen to visually show the data, they will give you wrong interpretation of the data. So again, they are still live, but maybe one example of this is speaking the y-axis. So these two graphs are the same thing, but here the y-axis is start of 30 points, whereas it's not a mediocre. So if someone just shows you this, what would you think? You would think that it's a huge difference, right? But it's not that big of a difference. You see the actual result, which we can get by exploring the data process. So another example of this is cherry-picking the data. So this is actually an example from an article where the user actually talks about the failure of the vaccination campaign in the US. So the vaccination campaign started in 2021, and so they compare the data of 2020 and 2021 and so there was limited changes. But this is not actually true. So because the claim said, so the claim that is very small. And in June of 2021, when the vaccination actually started, the number of cases had dropped in benches. The number of cases had dropped a lot. But they're not so much, and they're only so many cases. So basically, this led to the time frame that is most effective to their budget, which is mostly called cherry picking the data. Again, if we actually take the data set and if we actually analyze it, we can actually call it out and say that this is not correct and actually using credit data. So again, I would just like to say that exploration data analysis is very helpful because it can help us, before you start actually auditing the data, it is very essential for you to analyze the data. Because if you don't analyze the data, you will end up with anomalies, outliers, and just a lot of problems with your data, which you will have to deal with later and which can give long results. For example, if I had, in the previous data set, if I had a lot of characters, one data with a lot of characters and one data that just said yes or something one word, right? So that would create a lot of problems because if I am making a detection data set, it will directly categorize someone who says yes as depressed, which makes sense. So that's one. Huh? What? Yeah, so if you end up removing actual anomalies, anomalies that don't make actually causing some kind of issue. In the mental health data set, they were not causing any kind of issue because it was just a lot of text. But in something like transactions, if you are actually end up removing some huge transaction analysis and it ends up being a fraud, so it can cause issues.